Okay, moving on to determining if two triangles are congruent given one on a coordinate plane and the coordinates of another set. So it's asking us, are the two triangles congruent to PQR? So let's look at triangle ABC here. We're going to try to find distances between these points and see if it matches up with the distances between these points. So first, let's start by finding the distances or the side lengths of triangle PQR. P to Q is 1, 2, 3, 4. Q to R is 1, 2, 3. Now, I do not know this side length because I can't just count the way that I did on the other ones because it's not horizontal or vertical. I'm going to have to use the distance formula. So, using the distance formula, I'm going to say since R is at 1, 1, or negative 1, 1, and P is at negative 1, 2, 3, 4, 5, 1, 2, 3, 4. All right, I'm going to use the distance formula to figure this out. So, PR, the distance is going to be x2 minus x1, which is negative 1 minus negative 5 squared plus y2 minus y1 squared. So 1 minus 4 squared. All of that under the radical. So let's start to solve this. 1 minus negative 5. Minus negative 5 turns into a plus. So now I have 1 plus 5, so that's 4 squared. Plus 1 minus 4 is going to be negative 3. Negative 3 squared. Now I've got 16 plus 9. Remember, negative 3 times negative 3 is going to be positive 9. Now under the radical I have 25, the square root of 25, which is 5. PR, our distance, is 5. Using that distance formula, I'm going to have to do that to figure out the distance between A and B and C, and A and C. All right. I do notice some things about A and C. They have the same x value. If two numbers have the same x value, imagine them on a graph, or I'll put them on our right. At negative 3, 2, 1, 2, 3, 1, 2, and negative 3, 1. All right, negative 3, 2, and negative 3, 1. This would be A, this would be C. Since they're on the same x value, which is at negative 3, we don't need to use the distance formula because we can count, right? It's a vertical line. So going from here to here, how many units is that? 1. Did we have any other triangle side length that was 1? I don't think so. So that must mean that these two triangles are not congruent. What you want to do is test, either using the distance formula or graphing these points, to see if you're getting the side lengths of 3, 4, and 5. Once you find a side length that's not 3, 4, or 5, you can say, nope, not congruent. Give this next one a shot.